All right, so for today we are going to be talking about fluids and density in particular. Hey, just so you remember what a fluid is a gas or a liquid. So yes, there are differences between gases and liquids, but those differences are not going to matter for this chapter because we're going to be focusing on their behaviors that they have in common. All right, how they move around and all that stuff. So we're going to talk about density. This should be an old friend. Hopefully you know this already. Let's find out. So density, we're going to start with density. Density has a definition. Density's formula is this guy here. Now M stands for mass. Mass will be in kilograms or grams if you want to go chemistry, but we're going to stick with physics here. V stands for volume. Volume is going to be measured in meters cubed. Once again, you could use milliliters or liters if you're doing chemistry because it works basically the same way. And lastly, but not leastly, you have this guy, and that's density. I know, this is the Greek letter rho. It's not a P. I'm sorry it looks like one, but it's not. Anyways, your units for density are going to be kilograms per meter cubed. That is not the only unit that you're allowed, but that is going to be the one that I'm going to stick with as much as I can because that's what we're going to use in physics, especially coming up later in the week. Okay, so density is mass divided by volume. Something you should know if you ever have to deal with changing it from chemistry units. One thing you should know is a 1 milliliter is going to equal to 1 centimeter cubed. All right? So, and that's they're exactly the same. Okay? Now, that means that you multiply them by 100 times cubed. So, and you multiply this guy by 1,000. So this means that 1 meter cubed is going to equal 1,000 liters. Because this guy, you multiply it by 1,000 to go from milliliter to liter. This guy, you multiply by 100 3 times, which is going to be an extra 3 digits. That's why that's 1,000 liters there. All right, so we just want to make sure you're okay with that. Anyways, the most important value for density is water. Water has a density of a couple things here, but we're going to go with 1,000 kilograms per meter cubed. Okay, this is also equal to 1 gram per centimeter cubed, which is also 1 gram per milliliter. I'm sure you learned the last two in chemistry class, but the first one is what we're going to use most often here. Now, yes, to be fair, water does change density ever so slightly, but this is the standard one at about 4 degrees Celsius when it's at the maximum, and that's what they use most of the time. Now, it does vary, but it varies so little, so we just stick with that. All right, we have to talk about density's cousin. All right, density's cousin is called specific gravity. Now, this is density in comparison, basically. Okay, so let's say that I told you that a metal, because I don't remember one right now, a metal has 15 times the density of water. That's the specific gravity. Then it would have a specific gravity is equal to 15. Okay? So it's a ratio. That means there's no units because it's a comparison. It's how many times more dense than something. And it's 99.9% of the time going to be water. So it's a ratio. So water, for example, to be really lame, water has a specific gravity equal to 1. That means it's just as dense as water. If you're using chemistry units, you can just pretty much replace them. If you're using physics units like this, you're going to have to just multiply it by 1,000. It's way easier than it sounds, trust me. Just in case they throw specific gravity at you, it works just the same as density, basically, for all of our purposes at least. Let's keep going with a practice problem. What's the mass of air inside a small freezer with dimensions 60 by 85 by 100? And it gives us the density of air. So let's draw a beautiful picture of a freezer. Doesn't that look cool? That's right. Anyways, so we're going to have 60, 85, and 100 centimeters there. So to figure out the mass, we know that density is equal to mass divided by volume. Density is 1.29. Mass is what we're looking for. Volume, this is a rectangular prism. So we are going to have 0.85 times 0.6 times 1, right? Because remember, these are in centimeters. You got to switch them to meters because this guy is in meters. It doesn't really matter as long as they agree. You have to make sure they agree. We could have switched the density into centimeters, but that would not be worth it. I can tell you that. Okay, doing some quick maths here. The mass of this guy is going to equal 0.658 kilograms. And that seems reasonable because it's air. It doesn't have a lot of mass, and it's not a huge freezer. You know, take what you can get. Nice. We cool, we cool. All right, let's move on. A baseball diameter of that and a mass of this lands in water. Will it float or not? Well, let's see. Will it float or not? So what we're thinking about is the density of the ball going to be greater, less than, or equal to the density of water? Nice. So when we're thinking about our baseball here, it's going to be a sphere. So our formula is going to be the same. Rho is equal to mass divided by volume. We know what the mass is. The mass is 145 grams. So let's switch it to kilograms since we want to stick with that. I promise tomorrow it'll pay off sticking with kilograms. And then for volume, the volume of a sphere, do you remember that formula? It's going to be 4/3 pi times r to the 3. Now our radius here, oh, this is a diameter, so we have to do half of the radius. All right, so the radius is going to be 0.03734. All right, because we got to do half because it's diameter, change it to meters. Ah, the good old times. So you grind all this together, you're going to get 665 thereabouts. and this is in kilograms per meter cubed. Will it float or not? Well, let's see. The density of the ball is less than the water. That means it will float. Don't worry. You'll get your fill on buoyancy later. All right, so we compare the densities, and that's what we got. One more. A block of material has density P. Oh, how's that? Someone couldn't figure out how to use rho. A second block of equal mass has 3 times the volume of the first. What's the density of the second block? All right, so we have 2 blocks here. I've got this block. This is the first one. So it's got a density of P. And then I'm going to take this, I'm going to stretch it out, make it bigger. So this is times 3 volume. So we're trying to figure out what it's going to equal. So M is equal, whatever. Okay, so I know that P is equal to M over V. What is, the M doesn't change, the volume is 3 times bigger. So what's this going to equal? Well, if P is M over V, all these guys are P, so this is going to be 1/3 P. Hey, and that is it. Easy. As the volume goes up, the density goes down, as long as the mass stays the same. Nice. So we don't need to worry about units or anything, because it's a wonderful theoretical question. Easy money. All right, you have fun with those density problems, you hear?